Causal AI, or causality interference in artificial intelligence, is a revolutionary approach that enables machines to understand cause and effect relationships, ultimately leading to more accurate and reliable decision-making. Language models are expanding larger and more intricate every day. However, they're not exempt from their imperfections. Domain knowledge biases, untrustworthy predictions, and even hallucinations can afflict these models, leading to suboptimal results. However, a resolution is on the horizon for less bias and more responsible human-AI decision-making and knowledge work alignment. Causal AI. This innovative approach to AI, also called as causal interference machine learning, incorporates causality-inspired methods to alleviate biases, for example in domain adaptation tasks, improve out-of-distribution performance, and reduce knowledge conflicts in language models. In the emergence of natural language processing and LLMs, Causal AI can cover some of its shortfalls. It operates to de-bias large language models by diminishing entity and context bias. This not only enhances the precision of predictions, but also prevents the creation of deceptive information, known as hallucinations. Moreover, by incorporating causal reasoning, AI systems become more explainable and ethical. This is essential in a world where responsibility and transparency in AI systems are increasingly demanded. Causal intervention techniques hold the key to enhancing both white box and black box language models. By reducing biases and boosting accuracy, these techniques have significant implications for a myriad of business applications where high accuracy, reliability, and transparency is needed. They can ameliorate the reliability of language models in decision-making processes, ensure fair and unbiased language generation, and align AI systems more closely with human values. Here are a few ways causal AI could potentially fix some of these shortfalls. 1. Overfitting and hallucination. One of the main issues with LLMs is their tendency to overfit, leading to hallucinations or incorrect information being generated when confronted with out-of-distribution data. Causal inference techniques can help in reducing overfitting by identifying causal relationships within the dataset. By understanding these relationships, models can be trained on smaller datasets, thus reducing the likelihood of overfitting and hallucination. Number 2. Lack of transparency. LLMs are often considered black boxes due to their complex architecture and lack of interpretability. Causal inference methods offer a more interpretable way to explain model behavior, helping users understand how certain variables influence outcomes. This can be especially useful in decision-making processes where transparency is crucial. 3. Bias. Another issue with LLMs is the potential for perpetuating existing biases in the dataset. By incorporating causal inference techniques, models can learn from direct causes rather than correlations, reducing the risk of bias being unintentionally amplified. 4. Lack of generalizability. Due to their large dataset and overfitting tendencies, LLMs may struggle to generalize well across different contexts. Causal inference methods could potentially help improve this by focusing on underlying causal relationships that are more transferable across domains. The advantages of causal AI are vast. It can improve accuracy in sentiment analysis and content generation, prevent the generation of misleading information in news and content summarization, and increase explainability in sensitive domains like healthcare and finance. But where does causal AI fit in the actual world? Consider these 5 use cases. In supply chain planning, it can forecast disruptions and optimize operations. In healthcare, it can enhance medical diagnosis models, making them more interpretable. In finance, it enhances risk assessment models, leading to more precise predictions. In IT operations, it can form the foundation for reliable recommendations and automated responses. And in policy and development programs, it can make better causal inferences for more effective interventions. Voiceover. The application of causal AI techniques in a data-driven way with the Synaphin framework can be valuable for tech businesses and complex sustainability problems. The Synaphin framework is a sense-making tool that enables decision-makers to understand the nature of a given context, and it can be used for decision support in various domains, including responding to complexity and managing uncertainty. When combined with causal AI techniques, which focus on understanding cause and effect relationships in data, It can help in making sense of complex systems and identifying appropriate courses of action based on specific contexts. In the context of data-driven decision-making for tech businesses, the Cinefin framework can assist leaders in identifying the nature of the problems they are dealing with, whether they are obvious, complicated, complex, or chaotic. This, in turn, can help them choose the most suitable approach for decision-making. For instance, in a complex situation where traditional linear cause and effect relationships may not be readily apparent, causal AI techniques can be employed to uncover and understand the underlying causal mechanisms within the data. This can enable tech businesses to make more informed decisions when faced with complex problems or when developing sustainable solutions. By integrating causal AI techniques with the Cinefin framework, tech businesses can move away from a one-size-fits-all approach to decision-making and instead opt a more tailored and context-specific strategy. This combination can also help in developing a shared language and understanding within teams, leading to more effective and cohesive decision-making processes. From supply chain management and healthcare to finance, IT operations, and policy development, Causal AI is making waves to improve the reliability and transparency of AI where it's most needed. It is not just a promising approach to improving large language models, but a catalyst to advancing the development of more reliable and ethical AI systems across various industries. Therefore, the integration of causal reasoning into large language models isn't just a possibility, it's a necessity. By doing so, we can usher in a new era of AI, one that is more reliable, ethical, and in tune with human values. The future of AI is causal, and it's a future that holds immense potential for us all.